Hey everybody, my name is Calvin and welcome back to episode 3 of my Learn Python series. Today's lecture will focus on conditionals. As always, the course repository can be found in the description. If you haven't had the chance to watch episodes 1 and 2, be sure to watch those before tackling this one. Conditionals are how your program makes decisions. Without them, your code runs the same path every time. With conditionals, your program can react to the values in your variables and choose different paths. The structure we're learning is pretty much built around 3 key words: if, elif, and else. An if statement checks a condition. That condition must evaluate to a boolean value, which if we remember from our previous episode is true or false. If it's true, Python runs the indented block underneath it. If it's false, Python skips that block. If you include an else, Python will run the else block when the if condition is false. If you include elif, Python will try the next condition in order until one is true or it reaches else. One important Python detail: indentation is how Python knows what code belongs inside the if block. The code under the if is indented. When the indentation ends, the conditional block ends. That's why consistent indentation matters in Python. We'll cover these fundamentals in the exercises in this episode. Without further ado, let's create a lesson 3 folder. Lesson 3. And let's create our first Python exercise file for this episode, 3-1. In this file, I'd like to cover an exercise for your first if statement. The goal here is to make the true runs, false skips behavior obvious, like we covered before. Say we had age is equal to 17. We have an if statement that checks whether an age is greater than or equal to 18. If it is, it should print an error message that says something like, "You are an adult." Print this. When you run this file, we should only ever see this line print because of our age variable. Our age variable does not match the criteria that we've provided in this if statement, so it will never trigger this print statement. Because age greater than or equal to 18 is false, Python skips the indented block underneath. Now, we can change the value. Say we change age to 18. Now this conditional will evaluate to true, because age is indeed greater than or equal to 18. This is the core mental model for conditionals. Your code is branching based on true or false statements. Let's move on to the next exercise. In this exercise, I want to cover the else statement. Most decisions will have 2 outcomes. Else basically is how we can cover the otherwise. Say we had a variable called temperature. Is equal to 45. If temp is less than 32, we can print something. Oops. We can print a handy error message that says it is freezing. But if it isn't, we can print it is not freezing. When you run this file, it should make sense that the only line that is printed is this "it is not freezing" line down here. Because temp is not less than 32, we skip this else statement and we move on to the else statement right after it. We can see this in action. It is not freezing. Yet, if we change temperature to say 30, 30 is indeed less than 32. Instead of skipping this conditional, it'll go into the indented code underneath and run that. It is freezing. The takeaway here is that exactly one of these blocks will run, either the if block if the condition is true, or the else block if the condition is false. Moving on to the next exercise, I want to cover comparison operators. Comparison operators are what you use to create conditions. They produce booleans. Say we had a variable called a and a variable called b, and they were 10 and 3 respectively. For an equal to comparison, the way to write it is with two equal signs. And this means equal to. For not equal to, it is an exclamation mark plus an equal sign. And this will be your not equal to operator. Or this will be your not equal to comparison. Our greater than operator is simply this symbol right here, like you would see in math, and this is greater than the opposite. The opposite symbol works for less than. Now, if we wanted greater than or equal to, we have our greater than symbol and our equal to symbol, which just says greater than or equal to. And then you might have guessed by now, the less than or equal to is just like this. Let's walk through these. When you run this file, all these comparisons right here will produce Boolean values, meaning it'll produce us a value that is either true or false. So in this case, right, we have A is equal to 10, B is equal to 3. A is not equal to B, which is true. Greater than 10 is greater than 3, which is true. False. Greater than or equal to is true, since A is 10. And this should evaluate to false. We can confirm this by running our file. False, true, true, false, true, false. Exactly what we expected. A common beginner confusion here is mixing up equal and equal equal. If you have a single equal sign, that is an assignment. It sets a variable. A double equal equal is comparison, which checks equality. In an if statement, you use equal equal when you want to check, is this equal? So something like this. Would not work. This would not work and would give us an error. But if we added an extra one, this would work. And this should print us hello. Let's move on to our fourth exercise for this episode. In this exercise file, I want to cover Boolean operators, and, or, and not. Sometimes you need more than one requirement in a conditional. Boolean operators help us combine conditions. Say we had a variable called isMember, and we are a member. Purchase total, say we spent $120. Now, if we wanted to check a conditional, that is basically saying, if you are a member and you've purchased more than $100, then the condition triggers. This is what this is for. If is member and purchase total is greater than or equal to $100, print discount applies. Else, no discount. Oops. The AND Boolean operator here means both part must be true for the whole condition to be true. If either part is false, the discount won't apply. We can run this and confirm this. We are a member, and we've indeed purchased more than the defined threshold, so we should get discount applies when we run this. We can get discount applies. But if we negated either side of the Boolean operator, then it would go to the else statement, because this is an AND operator. Say we changed is member to false. Say we weren't a member. Now we are a member, but our purchase total has reached the threshold. That doesn't matter, because we need both conditions to be true. No discount. Same thing if we had true, but we spent less than threshold, no discount, or if both are false. Now, or means at least one part must be true. Say we had an is coupon is equal to false, and is VIP is equal to true. If we have a coupon, or we're a VIP, then the discount applies. Else, no discount. The OR operator makes it so either side of the conditional, only one condition or both needs to be evaluated true for it to trigger. So we don't have a coupon, but we are a VIP. This is false and this is true. But this will still trigger this conditional statement because one side is true. We run this and we can confirm discount applies. We can have both true, and this would also trigger. The only way we reach the else statement is if both conditions are false. No discount. Now let's cover the not operator. The not operator flips a Boolean. This is useful when a variable name already expresses a true or false state. Say we had an is locked variable is equal to false. And if not, it is locked. Print. You can open the door. Else, the door is locked. Here, the not of is locked becomes true when is locked is false. The idea is rather simple. The not operator simply reverses the truth value. So this is basically saying, if it isn't locked, you can open the door. Else, that must mean the door is locked. And if you run this, you can see that we've indeed triggered this conditional, even though this statement on its own, without the not operator, would go to the else statement. But since we have the not here, we basically reverse the false. The opposite is also true. Say we had is locked is equal to true, and if not true, then you can open the door. Else, the door is locked. In this scenario, we skip down to the else statement and trigger this code. The door is locked. Moving on to our next exercise, I want to cover elif chains. Elif lets you check multiple cases in order. Python goes top to bottom. The first true condition will win, and the rest are skipped. Say we had a score is equal to 82. If score is greater than or equal to 90, we want to award our student with a grade of A. If their score is an 80, greater than or equal to an 80, then we will award them with a B. Same thing for the letter grade C. And D. Our fallback here is an F. When you run this, it prints grade of B. The order here matters. If you put scores greater than equal to 60 first, then almost everything would match that early and you'd never reach the later cases. See, if we run this, we get to print B because first, it doesn't match this condition, so it jumps down to this elif statement right here, and it indeed triggers this, so we print a B. Since we've triggered this condition here, we're going to be skipping all the other options below. Now, if we had something like 60 up here, it is indeed greater than 60, and so it'll print an A here, and it'll skip everything else down here, rendering pretty much all this code useless, since it'll trigger this condition before it ever triggers anything else. That's why you want to be careful where you put if in your elifs. Now, if none of them match, then we fall down to our else statement right here. In this file, I want to cover nested conditionals. Nested if statements are just if statements inside other if statements. You use them when you have decisions that depend on earlier decisions. Say we had a variable called is logged in. We can set that to true for right now. And is an admin equal to false. If is logged in, then we print user is logged in. If the user is an admin, we want to display the admin panel. Else if this user isn't an admin, then we want to only show the regular dashboard. An else statement for a catch-all, direct to the login page. When you run this, it prints that the user is logged in and shows the regular dashboard. If you set is logged in is equal to false, you'll see it skip the nested part entirely and go straight to redirect login. The important thing to notice about nesting is just about this specific structure. The inner decision only happens if the outer condition allows you to reach it. Basically, what I'm saying is that this code block right here will only ever run if this exterior if is true. Even this inner conditional, if is logged in is false, it'll never reach here, regardless if they're an admin or not. And we can run this, and we can confirm. And that brings us to the end of lecture 3. As usual, we're going to get status. There's a slight change here. You can ignore that. I don't want this intro. You can see that we've added a lesson 3 folder. Let's add this. Lesson 3. Commit it with a message that says lecture 3 conditionals. And we'll push this. And that's the core of Python conditionals. You now know what a condition is, how if, elif, else control which code runs, how indentation defines blocks, how comparison operators create true and false values, and how Boolean operators combine multiple conditions. In the next episode, we'll build on this by introducing loops, which is basically how you repeat logic without having to copy and paste the same lines over and over. Thanks for watching, and I'll see you guys in the next episode.